Is my screen visible?
Yes, ma'am.
Yes. Okay, fine. Now, பேசுறது கேக்குதுல்ல? Somebody is talking, so that's why I'm asking. Yeah, வேற எதுவும் எனக்கு. Okay.
நீங்க பேசுறது கேக்குது.
Okay, fine. So in the previous class, we have started the next, third block that is about diffraction, right? So we know that what is called the diffraction and the basic, what are the basic examples in day-to-day life we have seen, and then what is called wavefront, and then what is about the size of aperture in the influence of this aperture to observe the diffraction pattern, right? And then what are the difference? This is the important thing about the difference between interference and diffraction. Diffraction and interference. See, in both cases, we are getting some fringes, alternate. Yes. So in both cases, we are getting the fringes patterns only, alternate bright and dark fringes. That is alternate consecutive and destructive fringes. But edunala kedikidundradha difference in our comparison, right? And then next thing is about types of diffraction. One is Fresnel diffraction, another one is Fraunhofer diffraction. So in this case, the types of diffraction la Fraunhofer தான் நமக்கு ரொம்ப quite easy compared to Fresnel diffraction. Schools la brief ஆ இதான் படிச்சிருப்பீங்க, right? So இப்போ இந்த நமக்கு UG லெவல்ல வரும்போது Fresnel கொஞ்சம் டிஸ்கஸ் பண்றோம், Fresnel diffraction பத்தி, right? So the analysis of this diffraction is quite difficult when compared to Fraunhofer diffraction. And then we have seen about Fresnel's half period zones, right? Half period zone na என்னன்றத நம்ம previous class, last class la நம்ம இத start பண்ணோம். So we are going to continue this. So next thing is about Fresnel half period zone la we have discussed about what is called a zone, half period zones, and we have calculated that area of the zone, half period zone, the area என்னன்றத find out பண்ணணும், which is a suffix n. This is about nth half period zone. Area is equal to pi beta lambda. Similarly, we have calculated for average distance of nth half period zone. அது நம்ம calculate பண்ணோம், இதோட stop பண்ணோம் previous class, right? Average distance of nth half period zone. We have calculated it is around b plus 2n minus 1 into lambda by 2. Now today we are going to continue this. See, நம்ம half period zone la area find out பண்ணிட்டோம். Similarly, average distance பண்ணிட்டோம். But one thing is important in this half period zone, Fresnel half period zone. நமக்கு கிடைக்கிற இந்த பாயிண்ட்ல கிடைக்கிற இந்த intensity, right? The intensity or amplitude of the wave. இங்க ஃபைனலா கிடைக்குது இல்லையா, after the diffraction pattern, we are getting some resultant wave, right? Here at this point. So what happens to the amplitude of the wave? So amplitude of the wave which depends on the intensity of the wave. Amplitude வந்து intensity எங்க ஜாஸ்தி இருக்கு எங்க கம்மி இருக்கு அதை டிபெண்ட் பண்ணி தான் amplitude நம்மளால resultant amplitude நம்மளால வந்து describe பண்ண முடியும், explain பண்ண முடியும். So now first thing is about come to amplitude due to a zone. Zone is nothing but the எல்லா ஸ்பேஸும் all half period zone combine பண்ணதான் நமக்கு, right? So இப்போ இதோட amplitude என்ன due to this zone, what is the amplitude? So actually this amplitude is depends on some factors, அதுதான் நம்ம பார்க்க போறோம். So amplitude of the disturbance at P due to any zone. So in the look at the diagram, amplitude at this point due to any zone, right? So it depends on three factors. One is it is directly proportional to area of the zone. Area of the zone we have calculated here. Area of the zone we have calculated, right? And then second thing is about it is directly proportional to obliquity factor. It is given straight away. It is 1 plus cos theta. In that factor directly proportional, right? Where theta is nothing but angle between the normal to zone and the line joining the zone to P. The ரெண்டுத்துக்கு உள்ள angle தான் theta, right? And then it is inversely proportional. Which one? The amplitude of that wave at point P. So which is inversely proportional to average distance of zone from point P. Average distance na நம்ம இங்க find out பண்ணுது previous ஆ. இப்போ என்னதுன்னா ஏரியாவுக்கு directly proportional. நம்ம அந்த factor சொன்னாலே obliquity factor 1 plus cos theta க்கு directly proportional. This average distance, it is inversely proportional. So that I can write this equation. Amplitude of the wave is denoted by the symbol R suffix F. This is due to nth half period zone. The suffix n, right? R is nothing but amplitude of the wave. So, இப்போ amplitude of the resultant wave நமக்கு பார்க்கணும். So, இதுல எதெல்லாம் depend பண்ணிருக்குன்னா, which is directly proportional to. Here I am considering this second factor alone. The previous case ல வந்து பாத்தீங்கன்னா ஏரியால நான் neglect பண்ணிருப்பேன். If this lambda value is very less than b, that b value means I have neglected, I have ignored this term. That's why I'm using this equation. If I'm considering this factor means the whole equation I have to write. So by considering this, I am writing this area of the zone in the equation and substitute right instead of this. So look at here. So this pi, this is nothing but simply I have taken this pi outside. In the term la நான் common pi எடுத்துட்டு இங்க mention பண்ணிருக்கேன். b lambda plus 2n minus 1 into lambda square by 4. Similarly, this is your area. This is the factor, and then obliquity factor. In the denominator, we have average distance. So by simplifying this equation, I am getting which is directly proportional to pi lambda. When you simplify this, you will get pi, lambda alone. So pi lambda into 1 plus cos theta n, where n is nothing but we know that it is the order of the zone. First order, second order, third order, up to nth order, last maximum order, right? So n is the order of the zone. When n increases, theta n also increases because it is directly proportional. N increase agumbodhu, which is here I have to put n suffix n, right? Yeah, n suffix r suffix n and number. So n வந்து increase ஆகும்போது theta also increases, but when you substitute in this cos theta value, it is automatically the value will be decreased. Cos theta n value will be decreased. Therefore, amplitude of the wave at point P, amplitude of the wave at point P due to a zone, particular zone, first zone or second, third, and right? Which decreases when increases. So, which means what? Are able to follow. இங்க பாத்தீங்கன்னா suppose the M1 இது first half period zone, second sphere. This is just I'm drawing. This is second period zone, second half period zone, third. Like this it will go on, right? So here I have to calculate the amplitude means what is the conclusion about this amplitude due to a zone. என்ன சொல்றாங்கன்னா amplitude of the wave இந்த பாயிண்ட்ல ஒரு particular zoneனால கிடைக்கிற அந்த amplitude will decrease when n increase. See, n increase na first order க்கு வந்து amplitude வந்து maybe ஜாஸ்தி இருக்கும். Second zone க்கு வரும்போது n value increase ஆகுது. n வந்து first previously 1, next n is equal to 2 means now the amplitude will be quite less compared to the previous one. Similarly, if you increase the next value for n, that is third, n is equal to 3 means next half period zone means automatically the amplitude will decrease. அப்ப என்ன ஆகும்னு பாத்தீங்கன்னா ஆல்ரெடி நம்ம இந்த டிஃபரன்ஸ்ல பார்த்திருக்கோம். என்னன்னா intensity of all bright fringes is same. இங்க பாத்தீங்கன்னா intensity of bright fringes will be decreased, right, when move from away from the center. அப்ப actually இங்க பாத்தீங்கன்னா நமக்கு கிடைக்கிற அது மாதிரி diffraction imageல பாத்தீங்கன்னா only few fringes are observed due to what? இங்க interference நமக்கு large number of fringes we can able to observe. But இதுலயே only few fringes தான் நமக்கு கிடைக்குது அப்படின்னா இந்த ஆம்ப்ளிடியூடுனால இங்க பாத்தீங்கன்னா நமக்கு ஒரு பர்టిక్యులர் ஜோனுக்கு அப்புறம் பாத்தீங்கன்னா அது அப்படியே இன்டென்சிட்டி குறைஞ்சிட்டே வரும், ஆம்ப்ளிடியூட் குறைஞ்சிட்டே வரும். ஆம்ப்ளிடியூட் குறைஞ்சிட்டே வருதுன்னா அந்த fringes வந்து we cannot able to observe. So this is the conclusion, that is amplitude due to a zone. So amplitude of the wave at point P due to any zone will be decreased when you increase the value of small n. That is the order of the zone. Clear? So next thing is about resultant amplitude due to entire wavefront. Entire wavefront na இப்போ நான் வந்து ஏதோ ஒரு ஜோனுக்கு half period ஜோனுக்கு தான் நான் இங்க மென்ஷன் பண்ணிருக்கேன். By considering any one. Yes. This is due to any zone. But now I have to calculate for this entire wavefront means this entire wavefront. Idhula na number of zones வந்து நான் வந்து consider பண்ணிருக்கேன் by Fresnel assumption, right? So entire wavefront means this ABCD. So what is the resultant amplitude due to entire wavefront ABCD? Now at point O, the phase of wavelet is simply 0. We know that. At point O, the phase of wavelet is 0. Then first circumference of sphere, that is M1. Inga enna phase அப்படின்னு பாத்தீங்கன்னா pi. Where is it? Yes. At M1, the phase of wavelet is pi. Now we have to calculate the difference. That is phase of wave coming out from the first half period zone is the average of these two. Average of these two phases, which is nothing but 0 plus pi by 2. Average na add பண்ணி divide பண்றோம் 2 ஆல. So you are getting only pi by 2. Similarly, phase of wavelet starting from second half period zone by considering this in the M1 ஐயும் M2 ஐயும். இப்போ நான் first consider பண்ணது இதையும். Right. Next பாத்தீங்கன்னா M1 and M2 I have to consider. Next case M2 and M3 I have to consider. Similarly, it will move on. It will go on, right? So இப்போ second case க்கு பாத்தீங்கன்னா I have to consider pi and the next sphere is 2 pi. Phase வந்து 2 pi. So இப்போ இங்க இது ரெண்டுத்துக்கும் average எடுத்தீங்கன்னா pi plus 2 pi by 2. So you will get 3 pi by 2. Similarly, you will get by considering the another two consecutive half periods one, we are getting 5 pi by 2. Similarly, 7 pi by 2 or 9 pi by 2, it will go on. So that is the wave arising from two consecutive zones will be out of phase. We are not getting the same phase difference, right? So two consecutive zones will be out of phase. So now consider if R1, R2, R3 be the amplitudes of wave. It goes on up to n, suffix R, suffix n, right? Amplitude of the wave. You know, already R வந்து amplitude. Excuse me. R வந்து amplitude of the wave. So instead of Rn, I'm just putting for 1, 2, 3, etc. So it is the amplitude of wave at point P due to the wavelets from first half period zone, second half period zone, third, and etc. Now, the resultant amplitude due to their superposition. Resultant amplitude now, it is due to only superposition of these waves. So I'm getting R suffix P at point P. Resultant amplitude at point P, which is equal to, this is the standard equation. This is the standard equation to calculate the resultant amplitude, which gives R1 minus R2 plus R3 minus R4. It goes on and up to minus 1 power n minus 1 into Rn. If it is even means you will get minus, actually here I have mentioned, yes. If it is even means I have to put Rn minus 1 by 2 minus Rn. This term alone also we have to include. So here these terms, that is, this is the equation to calculate the resultant amplitude at point P. Now I am going to write, that is, this equation can be rewritten as like this. Rp is equal to the first half period zone R1 divided by 2, and then the second half period zone, third half period zone, it goes on, right? So here, if I want to find out the amplitude of any zone, means it is the average of the previous one and the next one. Yes, suppose R2 in some book it is given small m, instead of this R, it is given small m. So if you are referring some other books, maybe in Bridgelal and Subramaniam, right? So here, this previous one, so R2 means second half period zone amplitude venue. So how I am calculating means by comparing the previous one and the next one. So R1 plus R3 divided by 2. Similarly for R4 means compare the previous one and the next one, R3 and R4. So the equation can be rewritten like this. Now, suppose if n is odd or even means, yes, that is the order of the zone. Odd or even now, maybe 1, 3, 5 or 2, 4, 6. And these two terms will be 0. Only thing is we are going to consider the first term and the condition for odd or even. So now look at this. The equation becomes, this thing alone you have to remember. So RP is equal to, if n is, that is n is odd means. So you will get the first half period zone R1 divided by 2 plus Rn divided by 2. This is the condition for if n is odd. Similarly, if half period, that is order of zone is even means, n is even means, by considering the first half period zone, so you will get, in both case, you will get first half period zone. So R1 divided by 2 plus, here it is Rn minus 1 by 2 minus Rn. So this is the condition for even half period zones, right? So now, when n is very large means, by considering n is very large, அதோட என்ன சொல்றது, மேக்ஸிமம் அந்த நம்ம கன்சிடர் பண்ற அந்த ஜோன்ஸ் வந்து ரொம்ப ஜாஸ்தி இருக்குன்னா, these two values are 0, which is Rn minus 1 as well as Rn. இந்த ரெண்டு கேஸ்லயுமே இந்த odd termல இருக்கிற Rn or இங்க இருக்கிற amplitude ரெண்டுமே 0 ஆயிடும். So only thing is we are getting the first term alone in both case. If it is odd or even, ரெண்டுமே இங்க நமக்கு large இருக்கும்போது இது 0 ஆயிடும். So only thing is I'm getting R1 by 2 alone at point P, amplitude, resultant amplitude at point P. This is the conclusion. What is the conclusion here? So resultant amplitude at P is the half of amplitude of wavelet from first half period zone. Yes, R1 is nothing but first half period zone. அப்ப அதோட half தான் நமக்கு இங்க resultantல கிடைக்குது. இங்க என்னவா இருந்தாலும் சரி, resultantல கிடைக்கிறது வந்து இதுதான். Now, already I told you that this amplitude is amplitude depends on the intensity of wave, right? So intensity at this point P means IP. Intensity at point P is proportional to amplitude square of amplitude, which means this is your amplitude. So take the square of this term, R1 by 2 the whole square. So it is directly proportional to, that is intensity is directly proportional to R1 square divided by 2 square, you will get 4. So intensity எப்படி conclude பண்ணலாம்? That is intensity at point is 1/4 of that due to first half period zone plate. Okay, resultant amplitude is nothing but half of the amplitude of wavelet from first half period zone. இது சொல்லும்போது intensity சொல்லும்போது 1/4 தான் நமக்கு தெரியுது. 1/4 of intensity due to the first half period zone alone. So this is the conclusion about the half period zone. Half period zone la நம்ம என்னெல்லாம் பார்த்தோம்? Area பார்த்தாச்சு, average distance, amplitude of any zone. By considering any zone, what is the amplitude? And then what is the resultant amplitude by considering the entire wavefront A, B, C, D, right? So what are the conclusion? Resultant amplitude at point P, what is that? Excuse me. What is the intensity at point P? So these two things we have to keep in mind, right? So next thing is about rectilinear propagation of light. I'm not going to explain in detail. So simply in the beginning itself, I've told you that rectilinear propagation, we know that light travels in a straight line. Light travels in a straight line, in the madri. Suppose you are using conventional light source, candle at you are just making 3 or 2 slits. Look at the another end. So light in the madri travel ஆகுது. இது natural நம்ம சொல்றோம். But actually it is not correct. Light is propagating. Rectilinear propagation of light. Propagation means like the spreading of light, right? In the madri lama, look at here. In the madri direction, when you are using a small slit, the madri circular slit nama use pandro or narrow slit use pandrona, we are going to see that direction of light is like this. Then the be exact at divarama, it's actually propagating, right? So this Fresnel's this theory is failure. That is rectilinear propagation of light. It is approximately, we can say that, right? So now this is the one brief about this rectilinear propagation, Fresnel rectilinear propagation of light. So actually it is not traveling. It is not travel. Light is traveling in a straight line. Instead, it is propagating, right? So we will get some shadows here. This region also it covers. இப்போ இங்க பார்க்கும்போது இங்க மட்டும் இல்ல லைட். சப்போஸ் தி பேக்ரவுண்ட் இஸ் டார்க் மீன்ஸ் இந்த ஸ்லிட் வந்து சப்போஸ் இன்னும் நேரோ பண்ணிட்டீங்கன்னா உங்களால எப்படி பார்க்க முடியும்? லைட் இங்க மட்டும் தான் வருதா? நமக்கு இல்ல. லைட் வந்து கொஞ்சம் spread down the geometrical shadow, right? So next thing is about the zone plate. This is another important topic in diffraction. So in this zone plate, we are going to see about the construction and theory. Construction and theory of zone plate. That's it. Yes. So what is called a zone plate? See, look at here. If an aperture is constructed so as to produce or so as to obstruct the alternate Fresnel zones. இப்போ நான் ஒரு aperture construct பண்றது எப்படி இருக்கணும்னா has to obstruct alternate Fresnel zones. Alternate Fresnel zones na you can assume anything odd or even. Here I'm considering even numbered zones. அப்ப even numbered zones na 2, 4, 6 அந்த half period zones எல்லாம் நான் block பண்றேன். அந்த மாதிரி I'm just constructing this aperture. Means say I'm getting this equation in previous amplitude at point P, resultant amplitude at point P. This equation, it's a standard equation. Here I'm just considering the odd terms alone because even numbered half period zones, I'm just blocking, right? So I'm getting Rp is equal to R1, R3 and R5. Like this it will go on. So such a specially constructed transparent screen இந்த மாதிரி எனக்கு கிடைக்கிற மாதிரி நான் டிசைன் பண்றேன் இல்லையா? So it is called a zone plate. Yes, specially constructed transparent screen is called a zone plate. Actually, this zone plate acts like a lens, that is a convex lens மாதிரி act பண்ணுது. Reason is this amplitude or intensity at point is much larger than if there were no aperture means. Right. So now come to the construction of zone plate. So in this construction part, we are going to consider concentric circles are drawn on simple white paper. Rings on the draw panning. Concentric circles are drawn. And then their radii, this is important. So different circles we have drawn, right? So radii are proportional to square root of natural numbers. See, radius means in the next case, we are going to see in equation. So radius should be proportional to square root of their natural numbers. And then odd number zones, because we are considering 1, 3 and 5, should be covered with blacking. Drop on a mode, it should be covered with blacking. And then reduced photograph on a glass plate is taken. And now look at this diagram. In the zone plate, odd half period zones are transparent. And then even in this zone plate, even number of half period zones are non-transparent. So resulting photograph transparency is given here. If this is the concentric circles we have drawn, right? So if the central zone is transparent in this case, here it is dark, right? The central in this zone is transparent means it is a positive zone plate. If the central zone is opaque or dark means we can call it as negative zone plate, right? So what about the radius of nth half period zone? Because we have drawn number of concentric circles, right? So the nth half period zone will be what? Rn is equal to, it is given, it is proportional to, see, radii should be proportional to square root of their natural numbers. So square root of b lambda. So what is n means? N refers to order of zone. 1 means here you have to write 1. 2, n is equal to 2 means 2b lambda. Like 3 means 3b lambda. So like that it will go on. So this is the radius of nth half period zone. Rn is equal to square root of nb lambda. Similarly, since area of each half period zone is equal, already we know that area of each half period zone is equal. What is that? Pi b lambda. Area is equal to pi b lambda, right? So here this radius given as for by considering n is equal to 1, 2, 3. It is square root of 1b lambda, 2b lambda and 3b lambda. Next. So what about the radii of half period zone are in the ratio of, that is R1 is to R2 is to R3 up to nth half period zone. So it will be like this, square root of 1, because b lambda is constant. B lambda is constant, so I'm just equating the ratio, square root of 1, square root of 2, square root of 3, 4, etc. It goes on. Right. Now come to the theory of zone plate. So already I told you that zone plate acts as a convex lens. So by first consider a monochromatic light source S. Look at this diagram, in this diagram, monochromatic light source. And this is your screen, XY. This is your zone plate by considering a point P. இது வந்து ஒரு கான்வெக்ஸ் லென்ஸ் மாதிரி ஆக்ட் பண்ணுதுன்னு நம்ம இமேஜின் பண்றோம், ரைட்? So S, that is source emits spherical wavefront of wavelength lambda. This source emit spherical wavelength, right? Waves of wavelength lambda. And XY is the section of zone plate, this one. Even zone plate, அதோட ஒரு section that I have mentioned here. So section of the zone plate, and SOP its axis. Zone plate or axis is SOP, which is perpendicular to plane of zone plate. That is SOP. Right. And then distance between S and O and OP is A and B. This distance is A and this one is B. Yes. So next thing is with O, by considering the O on the center, you just construct a half period zones on the plate XY. By considering O as center, we are going to draw the concentric sphere, right? And then the radii is given. PA is equal to R1, PB is equal to R2, and PZ is equal to R3. It goes on up to N. So PMN is equal to Rn, the radii of nth half period zone, Rn. And then what is Mn means? It is a point on the outer boundary of nth half period zone, which is given here, Mn. So now inga oru 3 half period zone da ABC ne eduthirken, right? So we are going to see that the path difference actually, right? So initially the path difference between SAP minus SOP. Where is SAP? This SAP minus this axis SOP, which is nothing but lambda by 2. We know this. Similarly, next one SPB minus SOP. Next concentric circle SPB minus this one SOP. Then next one, third, that is the last one. I have given the last one for nth half period zone, SMN suffix NP minus SOP. So in each term, I'm getting the difference is 2 lambda by 2, and next case 3 lambda by 2, it goes on. So for nth half period zone, the difference between these two rays is called n lambda by 2. Right. So the path difference from one zone to next zone, it increases by lambda by 2. Yeah. First lambda, second case 2 lambda by 2, next 3 lambda by 2, up to the last one, nth half period zone, I'm getting n lambda by 2. Now calculate the radii of nth zone by considering the triangle SMNP. Yes, SMNP. In the triangle na consider pandra. Next case in the triangle na consider panna. So calculate, in order to calculate the radii of nth zone, enakku calculate pannu. So I'm just considering this triangle. From this, you find out what is SMN. SMN hypotenuse is equal to square root of a square plus Rn square. Yes. So here you just take this a square outside. Square root la irukku. Square root la irukkumbodhu a square na velila irukra. So I'm getting 1 plus Rn square divided by a square into the whole power of 1 by 2. And then next case, you just simplify this. So I'm getting a into 1 plus the 2 in the denominator, Rn square divided by 2a square. So next case, you just multiply with this a. So I'm getting what? A plus, again, one a will get cancelled. So Rn square divided by 2a. So mark this equation number 1. The previous one is as 2, 1. This one as 2. Similarly, by considering the next triangle, the right hand side part, that is OMNP. OMNP. So this distance is small b, right? So here I'm just writing the value of PMN, which is equal to this one. PMN is equal to square root of b square plus the nth, because I'm considering MN. So Rn is the radius of the nth half period zone. So here square root of b square plus rn square. So I can write take this b square outside like the previous one. Every a square at the b square. So you will get 1 plus rn square divided by b square. In next case, b into 1 plus, because this 2 will come to the denominator. And then next you just multiply with this b. Inside kondu vaanga. So simplify this, you will get b plus rn square divided by 2b. So now from equation 1, in this equation I'm going to substitute the values. What is there? S, M and P minus SOP. SOP means what? Look at the diagram. SOP means what? A plus B. Excuse me. SOP means simply A plus B. And what is SM and P? SMN I have calculated here. And PMN also I have calculated. SMN P I need. So that I have to add these two. I have to add these two. I will get SMNP. So A plus Rn square by 2A plus B plus Rn square by 2B. That is your first term. I'm just rearranging the equations. So A plus B plus Rn square by 2A. Similarly, Rn square by 2B. Minus SOP is nothing but A minus B. So simplify this equation. How? This A plus B and A minus B will get cancelled. So Rn square by 2A plus Rn square by 2B. Take the common terms outside. Rn square by 2 is common. So you will get 1 by A plus 1 by B. Mark this equation number as 4. So compare the previous equation 1 and the recently found equation. Ipo number 4th equation in the first equation you compare because left hand side are equal. Right. Equate right hand side equate. So Rn square by 2 into 1 plus A plus 1 by A plus 1 by B, which is equal to n lambda by 2. N lambda by 2 is from equation 1. This is from equation 4. So simplify this, 2 will get cancelled. So Rn square is equal to n lambda divided by, you will take this term to the opposite side, denominator. So 1 by A plus 1 by B. Take the LCM. So take the LCM. So you will get B plus A by AB. In the term B plus A by AB. In the AB, numerator get that. So I'm getting AB n lambda divided by A plus B. So Rn square is equal to this value. So Rn is equal to square root of AB lambda divided by A plus B into, I'm just rearranging for my convenience. This is root n. So from this I can conclude that the radius of nth half period zone is directly proportional to order of the zone. Square root of order of the zone. இப்போ நான் இங்க என்ன வருதோ அதுக்கு ஸ்கொயர் ரூட் டிபெண்ட் பண்ணி இருக்கும். ரைட். ஸோ இப்போ இங்க வந்து 5 இருக்குதுன்னா 5th half period zone இருக்குதுன்னா இங்க 5 square root of 5. So from the equation, previous equation, that is from this equation, 1 by A plus 1 by B is equal to n lambda divided by, take this Rn square to opposite side, that is Rn square here, denominator. So I can write this as 1 by Fn. In the term ku badala 1 by Fn and podren, because this is from Lenz law, mirror law, Lenz law லாம் படிச்சிருப்பீங்க இல்லையா? So adala Fn is nothing but Lenz law formula pathina 1 by V plus 1 by U is equal to 1 by F, focal length. So from this I can write Fn is equal to, see 1 by Fn is equal to this thing. So Fn is equal to, interchange this. So Rn square divided by n lambda. So this equation is just like mirror formula, Lenz formula. So where A is the object distance, B is the image distance, and Fn is the focal distance of zone plate. So what is the conclusion here? So zone plate behaves like a converging or convex lens. So it is variable focal length, which has convex lens of variable focal length. Why? This is the major difference between zone plate and convex lens. Convex lens la ஒரே focal length தான் இருக்கும். But in the zone plate la they are considering so many half period zones, right? அப்போ அதோட focal length different since it varies with n. Right. So this is the conclusion about zone plate. இப்போ என்ன பார்த்தோம்? Zone plate ஓட construction, as well as theory, and then comparison with convex lens, which we are going to see now, right? The convex lens is solid compare before that we have to see what is called multiple foci of zone plate, because convex lens, but zone plate has multiple foci, right? So from this equation here, that is from this equation 8, Fn is equal to Rn square divided by n lambda. So from this I can say that focal length of a zone plate, that is Fn, is directly proportional to square of the nth half period zone, radius of nth half period zone, and it is inversely proportional to the order of zone n. Which means what? For different half period zone, the value of Fn is also different. ஏன்னா ஒரு ஹாஃப் பீரியட் ஜோனுக்கும் இந்த ஃபோக்கல் லெங்த் இருக்கு இல்லையா, எஃப்என் இருக்கு இல்லையா, அது வந்து உங்களுக்கு டிஃபர் ஆகிட்டே தான் இருக்கும். ஏன்னா இங்க ஒரே ஒரு இது மட்டும் கன்சிடர் பண்ணல, we are considering so many half period zones. So conclusion is, which shows that zone plate has multiple foci because it has so many half period zones. And then now compare with zone plate, that is compare with convex lens. So first let's see about the similarities between zone plate and convex lens. And then we'll move on to the difference between zone plate and convex lens. See, what are the similarities? So similarities given here. First thing, focal length of a zone plate and convex lens. If ரெண்டுத்துக்குமே convex lens லையும் சரி, zone plate லையும் சரி, focal length F depends on wavelength. Lambda depend பண்ணி தான் இருக்கு. Hence, both show chromatic aberration. Chromatic aberration from first year நம்ம படிச்சிருக்கோம், which is nothing but about colors. அந்த colors நம்ம colorsல கிடைக்கிறது வந்து உங்களுக்கு colors identify பண்ண முடியாம கிடைக்கலாம், இல்ல அது வந்து blur-ஆ இருக்கலாம், narrow-ஆ இல்லாம point correct color நம்மளால identify பண்ண முடியாம இருக்கலாம். அப்போ colors always, colors of any object depends on the wavelength of light, இல்லையா? அதோட wavelength depend பண்ணி தானே இருக்கு. So it shows in both case, zone plate and convex lens, it shows chromatic aberration. Now next point is both zone plate and convex lens form a real image and inverted. ரெண்டுமே எப்படி image produce பண்றது எப்படி இருக்கும்னு பார்த்தீங்கன்னா ரியல் இமேஜா இருக்கும், as well as inverted image. இப்போ ஆப்ஜெக்ட் இப்படி பிளேஸ் பண்ணி இந்த டைரக்ஷன் அப்போர்ட் டைரக்ஷன்ல இருக்குன்னா இந்த இமேஜ் பேட்டர்ன்ல யூ கேன் ஏபிள் டு see that towards down இந்த மாதிரி இருக்கு, ரைட்? So in both zone plate and convex lens, it forms real image of an object on opposite side of the object, which means inverted image, real and inverted image. And then third point, so formula connecting conjugated distance in both cases are similar. என்னன்னா அதான் lens formula and zone plate formula. Lens formula என்ன 1/v plus 1/u is equal to 1/f. Zone plate formula என்ன இப்போதான் நம்ம இதுல பார்த்தோம். Zone plate formula, which is r n square by n lambda is equal to, it is given sorry, n lambda by rn square is equal to 1/a. It is nothing but we can write 1/v. 1/a plus 1/v is equal to this thing. So when you compare, you can write 1/v plus 1/u, which is equal to n lambda by rn square. So these are the similarities between convex and zone plate. And then what are the dissimilarities, difference between these two, zone plate and convex lens? First point, zone plate இப்பதான் பார்த்தோம், it has multiple foci, right? ஏன்னா அதுல நிறைய உங்களுக்கு வந்து spheres நம்ம கன்சிடர் பண்றோம், right? So half period zones. So it forms series of point images of decreasing intensity for a point object. இப்போ இங்க ஒரு point object இருக்குன்னா intensity decrease ஆற மாதிரி image வந்து நமக்கு கிடைக்கும், நிறைய images கிடைக்கும். It forms a series of point images with the decreasing intensity. Intensity குறையும் போது தான் நமக்கு amplitude குறையும், அப்ப first few fringes மட்டும்தான் அந்த இதை மட்டும் தான் நம்மளால பார்க்க முடியும். Then convexல பார்த்தீங்கன்னா it has no multiple foci. Second point, the focal length of red color. Focal length of red color in zone plate, I'm telling, is less than that of focal length of violet color. But இது அப்படியே opposite convex lensல. focal length of red is greater than that of focal length of violet color. அப்போ இது வந்து என்ன சொல்லலாம்? The order of colors in the chromatic effects are opposite in both case. இதுல ஒரு order இருந்ததுன்னா இதுல அப்படியே opposite orderல form ஆகும், right? And then third point, path difference. So in zone plate, it has a path difference, but இங்க பாத்தீங்கன்னா convex lensல follows the same optical path. See here, the path difference between the rays from two successive transparent zone is given by lambda by 2. But in this case, convex lens, all the rays reaching an image point have same optical path. And then last one, image formation is less intense in this zone plate, but convex lens la pathina image formation is more intense. Zone plate la due to diffraction, image formation is compared to convex lens, we are getting only less intense pattern. Inga vanda more intense pattern kadikira image. So these are the difference between zone plate and convex lens. So this is one important topic. So half period zone na enna, zone plate na enna, theory and construction, as well as the how we are relating this zone plate to convex lens. So these things you have to write under this topic. You have to study. And then next thing, I'll just try to finish this. So next thing is about diffraction at a circular aperture, as well as due to circular obstacle. Diffraction நடக்கும்போது இது beginning I have told you in the beginning itself. எங்க சொன்னேன் நான்? நேரோ இங்க ஒரு அபர்ச்சர் யூஸ் பண்ணும்போது எப்படி இருக்கும், ஒரு ஸ்மால் அப்டக்கிள் யூஸ் பண்ணும்போது எப்படி இருக்கும், இந்த ஜியோமெட்ரிக்கல் ஷேடோ எங்க இருக்கும், இங்க ஜியோமெட்ரிக்கல் ஷேடோ எங்க இருக்கும். ஸோ இப்போ இதுதான் அங்க பார்க்க போறோம். ஸோ diffraction at circular aperture and due to circular obstacle. Circular obstacle வைக்கிறோம், ஒரு slit மாதிரி வைக்கிறோம். So look at here. So AB is narrow circular aperture. So now parallel beam of monochromatic light source இங்க வந்து incident ஆகுது. In the case, circular aperture case. Now center P region, A dash B dash is bright or dark. In the region the bright or dark இருக்கலாம். And around P, இத சுத்தி வந்து இது வந்து bright the center வந்து bright or dark இருக்கலாம். இத சுத்தி alternate bright and dark fringes will be observed. And then above point A dash, இதுக்கு மேல இது screen, X point of the screen, இதுதான் the slit. I'm just incident of the wavefront here from monochromatic source. இப்போ இங்க பாத்தீங்கன்னா இங்க A dash B dash போட்டுக்கல, இதுக்கு மேல A dash க்கு மேல இங்க B dash க்கு கீழ. That is, the intensity of light falls rapidly and becomes zero at some point. இங்கதான் intensity வந்து கொஞ்சம் கொஞ்சம் எனக்கு பாக்குற மாதிரி விசிபிளா இருக்கும். இதுக்கு மேல போக போக ஆட்டோமேட்டிக்கா intensity வந்து இதுக்கு இந்த சைடு போக போக குறைஞ்சிட்டே வரும். அதனாலதான் நமக்கு டைரக்ஷன் பாத்தீங்கன்னா இவ்வளவுதான் இருக்கும். லைட் நம்ம ப்ராபகேட் பண்றோம் அப்படின்னா இவ்வளவுதான் டைரக்ஷன் இருக்கும். அதுக்கு மேல போக போக நம்மளால ஐடென்டிஃபை பண்ண முடியாது. Right. Now in this case, instead of circular aperture, I'm just using obstacle. Place பண்ற obstacle place பண்ற. இப்போ இங்க பாத்தீங்கன்னா the diffracted pattern. இங்க பாத்தீங்கன்னா உங்களுக்கு கிடைக்கிறது center is always bright. இந்த part வந்து always bright due to circular obstacle. And outside the geometrical shadow will be there. That is, brighter and broader rings are obtained. இதுக்கு மேல பாத்தீங்கன்னா geometrical shadow. இதுக்கு இங்க பாத்தீங்கன்னா it is outside the geometrical shadow, brighter and broader rings are obtained. இதுக்கு மேல. So this is the difference between diffraction at circular aperture as well as due to circular obstacle. So next topic will continue in next class, right? So tomorrow we'll continue about transmission grating and then experiment theory, and then we'll move on to optical instrument, resolution of optical instrument. In that we are going to discuss about telescope and microscope. What is the condition? So with that the unit will be over. Third unit will be over. Then we'll move on to actually fifth unit. After completing third unit, I will move on to fifth unit, which covers spectroscopy and laser physics, right? Spectroscopy உங்களுக்கு ஒரு just introduction தான் இருக்கு, ரொம்ப detailed right? Similarly lasers, usually lasers and holography எல்லாம் include பண்ணிப்பாங்க, but in your syllabus it is given laser. So it's like a story madri. I will try to finish within 1 or 2 hours. Then we'll move on to 4th unit, which is about polarization, right? So thank you, students. We'll continue in next class. That is tomorrow we'll continue.
Thank you, ma'am. Thank you.
Thank you. Thank you.